Okay, let me know if y'all can hear me. Um, and we will begin. Okay. So in the last one, on Monday, we had set up some basic MySQL stuff. So we went over some MySQL. And we also set up a schema here. And we were just trying to, we looked at the Figma, right? Basically, what is this social media application supposed to do, right? What's the kind of data that we're kind of, expecting and stuff like that. So, we kind of, just went, we looked at it and then we just started, thinking, okay, well, these are going to be the names of the tables, and then these are going to be some of the columns. And so, this is very vague. So we left off at posts. I don't think we did all of them, at least all the columns. So we'll just finish that up, and then we'll talk about service layers and stuff like that. Okay. So we have the posts, and we ended up at location. So the location was supposed to be some kind of like GPS coordinate, right? So that's just going to be a string. So it's just gonna be characters. We just set that to like 128 characters right there. And then we have the image URL. Okay. And this one could be null. Maybe they don't put an image. That's fine. And now the tags. So what we ended up doing was I explained that it's probably better not to have the tag directly onto the post. What we'll do is we can we will have to parse the the stuff that somebody posts, and we're gonna have to look for those hashtags, right? These pounds, we're gonna have to parse these out. We have to find all of them. Once we find them, we're going to add an extra um, level of complexity by being, okay, here's the post information, and also here are all the tags that are related to this post. So what I think we should do is we should create another table, a separate table that has the tags. So we have a tag ID and then the tag text. So these will be all in lowercase. So basically we're going to ignore case sensitivity, okay? By having them all stored in lowercase. And then what we're going to do is we're going to have another table called tag usage. Now what this is going to do is it's just going to be a table, right? That is going to have the tag IDs associated with a post ID. Okay? So that later on, if somebody were to, tap on a tag, I think Twitter has this, and I think Facebook as well. If you tap on a tag, then it'll show you all the recent posts. Well, it's going to show you all the posts that have ever used that tag in their comment or in their post, right? So we can do that. So I think the easiest way is to just leverage using a table. And so this tags table and this post table, we will join them by using something called a joint table. So this is how we're relating them. So that's why we're not going to have the tags directly inside of this post like that. We're not going to do that. Okay. Next. Actually, let me look at the Figma. Because maybe we have an area, right? Before they put a post, maybe we have an area where you can like add a tag. So if a tag already exists, you can just use that tag. See, and I think that'll work for us, because if we look at here, we have these tags. It's almost like they're not part of the post. So what we can do is, yeah, so this is actually making more sense now. what we can do is we can add a tag and then we can remove tags. So we'll have this little area right here. So we should probably have another button or something like that where it can add a tag. So it's not going to be as dynamic as Facebook. They had a longer time to build their website. We're trying to build this thing really, really quickly. So I think this would probably be the easiest way. And you'll see what I mean once we get there. Okay, I'm gonna close this. All right, the likes and the dislikes. Okay. So we can, in fact, keep track of these. And I'll show you how we're going to do this using something called triggers. So I'm going to create the likes. This is going to be an integer, unsigned. Then we're going to have a dislikes. This is going to be an integer, unsigned. Okay. Comments. So a post should have comments, correct? But it's not like we're going to put the comments in this record, right? Because remember, a table has rows and columns where the rows are individual entities. We call these records. And the columns are going to be, where the actual data is actually stored. So each column represents a different piece of data, and an entire row, which basically encapsulates all of the columns, is what we call a record. Now, it doesn't make sense to put the comments here directly on the post because there can be multiple comments. So what do we need to do? We need to break this up, right? Because one post can have many comments and there's no way to represent that in a single record. So what we then have to do is we need to create a comments table. So we need to create a comments table. So we'll have something called, like, let's say, well, each comment needs to obviously be referring to a specific post, right? So we can have a post ID, okay? So this post ID is this post ID. In fact, I will start renaming these like this so it makes more sense. Okay, so this comment has to refer to a specific post. Okay, and we need to have, well, I guess what we'll go first would be some kind of comment ID. So we'll do a com ID. So it's a comment ID. This way we can refer to this very specific comment. In the case that we need to delete it, how do we delete it? Well, we need to know its ID. So we're going to have a comment ID. We need to have a post ID in which this comment is supposed to refer to. And then again, we have, the text. So we'll have some text, for example. Okay. And if we want to have likes and dislikes on the comment, we could probably do that too. For now, we'll just leave it as just a regular old comment. Okay. Next, we have this created date. So we want to have a way to keep track of the date. So what I'm going to do is I'm going to keep track of the date as a string. So I'm not going to use a date object. Instead, I'm going to use a number. I'm going to use something called a Unix number. So we're going to use that to keep track of time. So I'm going to have this called created date, integer, unsigned. So it's going to be a number. And then the last time this was edited date, integer, unsigned. And the created date cannot be null. So if for some reason we tried to create a post, but we forgot to put in the created date, it's going to die. Okay, it's going to fail. So we need to have a created date. That is a requirement, so this cannot be null. Okay, so now let's do some easy stuff here. So let's look at the well, I guess we need to create a table. So we need to create a table to store the comments associated with a post. So we're going to do that here. So create table if not exists, We're going to call this, we'll just call this comments. Okay, here we go. So this comment needs to have a comment ID, which is going to be an integer. It's going to be unsigned. It cannot be null. And it's going to be auto-incremented, and it's going to be the primary key. So the com ID will just be a number. Now, in an ideal world, the comment ID should not be an integer. In fact, a lot of these IDs should not be integers. They should be randomly generated strings, specifically like, base 64 or something like that. Again, because we're using incremental IDs, if we had, if this was like a legit social media website, our competitors could actually figure out how many users we have. Now, in the beginning, the amount of users you have, you don't want to be telling, because you want your competitors to see you as a threat. But if they look at your website and they just do some simple math, right? So they write a little script, they can figure out how many users you have if all your IDs are just auto-incremented. They just have to keep checking until they get a 404. They're like, oh, okay, well, you have 5 users, but you definitely don't have 6 users because user ID 6 doesn't exist. Therefore, it must be the case that you have at most 5 users, right? It's very easy to figure out how many users you have. So they won't see you as a threat. But if you use these randomly generated IDs, they have no idea how many users you have. You could have 1, you could have 1,000,000. They really don't know, right? So these are some, analytics data that you don't want to be sharing with your competitors, okay? For the sake of this project, we're going to use these auto-incrementing IDs, okay? It's okay for this, but I will leave it as an exercise for you guys to figure out how can I change this up. So instead of having auto-incremented IDs, I have something more unique. And it's really not that hard to do. All you have to do is change one of these. For example, like the post ID should just become a string. But how large is that string going to be? That's the next question. And all you got to do is slap primary key on it and you're good to go, right? So all you have to do is change this and make it into a string. Okay. Now, I'm not going to get into it, but find a way to make it, cryptographically safe, so you don't run out of keys too quickly. If you use base 64, that uses, so base 64 uses A through Z capital. It also uses A through Z lowercase. It uses 0 through 9 numeric, and then it uses a hyphen and underscore symbol. This totals to, you have 26, you have 26, and then you have another 10, and you have 2. That becomes 64. So you have 64 characters that you can play with, right? You have 64 characters. So if you wanted to have an ID of size 4, how many possible IDs could you generate from a size of 4? For example, if you had a varchar of 4, how many possible IDs could you actually create? Well, that's 64 to the 4 possible IDs, right? Because there's 64 possibilities for each character, and you have 4 of them, so it just becomes a basic, combinatorial equation, right? There you go. You have 64 to the 4. So if you change it from a 4 to a 5, you just added you just multiplied that whole space by 64. So it just keeps getting bigger and bigger and bigger. So you could totally, you could do that. We're not going to do that because I don't want to, talk too much about these kinds of things because I'm just trying to make it easy. But just know that that does exist, and I know that this is not the correct way, but this is supposed to be, a learning environment. So we'll just keep it like that. All right. Now this comment needs to refer to a post. So we have again another foreign key. So this is just an integer, and this is going to reference the posts. Okay. And in the post table, we're going to refer to the post ID. Now again, these two don't have to be the same name. but it makes sense that you make them the same name. It just makes it easier to, it makes it easier to know what the heck we're talking about here. Okay, so we know that this post ID is coming from posts. Okay, but again, you don't have to. In fact, sometimes some people will do like FK underscore post ID, for example, like foreign key, to just indicate like, hey, this post ID is not actually defined here. The actual definition is coming from somewhere else. So, that's you could do that. Okay. Next is the text. So we're here just going to have the text. So we'll do a varchar. Okay, variable characters. So basically now it's like, okay, how long do you want the text to be? How long do you want a comment to be? So a post can have at most 1,024 characters. So maybe a comment has that many. Maybe we'll do 512, right? I don't know. See, this stuff is really hard. Just really depends on what you want to do. Okay. Image URL. Actually, do we want to have? No. So that's it. Okay. So they can only comment with the text. Okay. If you want extra features like likes and dislikes on comments, again, I leave that as a, what do they say? As an exercise for you to add those. You already have examples of how to do it, so you just have to figure that out. All right, next, create a table that stores all possible tags. These will be auto-generated based on content. So the tags, maybe in the beginning, we'll have like, 5 tags. Hashtag, I don't even know what our thing is called. What is our social media even supposed to do? I don't even know. It's supposed to be like Twitter, right? So, but it's called bitter. So I'm not entirely sure what the theme here is, other than it being bitter. I'm not entirely sure what it's supposed to do. So, oh, didn't we? I don't know. What do you guys think? What should be like the overall arching theme of our social media website? What's the theme? You know, um, I'll give a second to somebody tell me what's the theme, because then based off the theme, we'll know what kind of tags we should have by default. Like hashtag, um, you know, hashtag entertainment, hashtag philosophy, hashtag health, hashtag computers, hashtag science, whatever. Feels bad, man, whatever. I don't know. Create table. If not, we didn't think that far ahead. No, we did not. So now we need to figure out how the data is going to look. It's kind of hard to build a system where you don't really know what you're actually what your site's actually supposed to do. So here we're gonna call this tags. So here we'll have a tag ID. It's going to be an integer. It's going to be unsigned. And for tags, it's okay. It's okay to know how many tags. That kind of information, who gives a shit? That's not enough information to make any level of sense to hide. You could, if you want to go that extra mile and like have your competitors really not know anything about what you're building, or even at what state you're in. That's totally fine. I think that's overkill, but then again, I'm not a billionaire, so I can't really tell you what would be the correct way to do that. And then we'll call this so we'll have a tag ID, and then we'll have the text. Instead of calling it tag text, I'll just call it text. Varchar. So a tag, a hashtag, now I have to figure out, okay, how big of a hashtag should we have? And I honestly think a hashtag should be no larger than, like, let's say 16 characters, or maybe we'll say 32. We'll just say 32. Okay, and this cannot be null. There's no point in adding a tag into our table if it's null, right? It makes no sense. The other thing is, it has to be unique, right? You cannot have multiple tags in here. The whole point is that these tags should be unique. So if somebody were to misspell a tag, that's going to add an extra tag into the record, right? So hopefully they don't misspell it. But if they misspell it, it's, there you go. You're going to get another one. Okay. Maybe there's ways that we could clean it up later on. I don't know. We'll see. Food, because everyone loves food, but we kind of did that last time. Okay. Um, yeah, I mean, we have a site called Bitter, so we know. I mean, I don't know. I don't know what to do with that. I don't know what it's supposed to do. Okay, so now that we have our tags, now we have the tag usage. So we can call this, um, yeah, we'll just call this, okay, so create table if not exists. We'll call this tag usage. Okay, so the tag usage is going to work like this. We're going to have a tag ID, which is an integer, and this is a foreign key. And this is going to reference the tags, tag ID. And then in here, each tag is going to be associated with a specific post. So now we have a post ID, which is also an integer. And this also references the post's post ID. So you'll notice that this table is made up of 2 foreign keys. So that's an interesting one. Could even just make it pet photos. Sure, it's just supposed to be a Twitter clone, so like sharing what your day was like, photos of your food or beaches, etc. Okay, yeah. I mean, again, doesn't matter. This is like, if you notice here, the theme here is so generic. This can literally be anything. It's so generic. All right, now we have the followers. So create table if not exists the followers table. Okay. So this followers table is a joint table between 2 separate tables. Okay. So this column, so let me get my awesome drawing tool here. We have a table that's going to have 2 columns here. Okay. This is called the followers. Whoops. Okay. So you're going to have some IDs here. And the interesting thing is that this is a user, well, I'm not even going to try, just user ID. And this is also a user ID. And so both of these IDs are going to be referencing our users table. So here's our users table that we have over here. We have like 1 billion users, something like that. So, if we have some records here, okay, let's say that this is the user ID, right? And then here we have, let's say this is F name. Okay. And then dot, 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 dot. So let's say here we have me. So we have Kevin. We have Bob. And then we have Jane. And this is user ID 0, 1, and 2. Okay. So basically, this is how the followers table is going to work. So let's say I see a post from Bob. Okay, and I'm like, oh, this Bob, he's so funny, right? He's like, he's a comedian or something like that. So I was like, oh, okay, I want to follow this guy. So on my news feed or my feed or whatever the heck you want to call it, I can see Bob's posts, so I can like look at them and laugh because he's a comedian or something like that. Okay. So the way it works is when I say, hey, I want to follow Bob, what this table is going to do is basically it's going to create that connection. So I, who am the follower, will go on the left side. So there's my ID, 0. And then the followee, I guess, would be Bob. So he'd go on the left, on the right. So now we say user ID 0 follows user ID 1. And once we look them up into the table, it's like, okay, who the heck is 0? Oh, that's Kevin. Kevin's following Bob. See how this works? And then if Bob sees that I comment on one of his posts, he's like, oh, dang, Kevin's pretty cool, And he's like, yeah, I want to follow Kevin too. I want to have his stuff pop up on my feed too. So then he looks on my profile and hits follow. So now it's going to be like, so now Bob follows Kevin. So see? So this is how Twitter has it. So I think Twitter has it where like you can follow people, but they don't necessarily have to follow you back. So having a table like this shows, okay, Kevin is following Bob, but that doesn't necessarily mean that Bob is following Kevin. In this case, if Bob decides to follow me, then he's going to be on the left side now, not just the right side. So if Bob is like this super awesome comedian, then it's possible that Bob, if he's like a, what we call him, an influencer or so like a celebrity, it's Bob's going to show up on the right side a lot, especially if they're very popular. So Bob will show up here. Let's say Jane follows Bob. So you notice that Bob shows up here and here. So if you ever want to know, okay, how many followers does Bob have? All you have to do is count the amount of times that Bob shows up on the right side. So in this case, Bob has 2 followers. That's very easy to do. And that's a very simple SQL statement, SQL query that we can do. Is basically how many times does Bob show up on the right? User ID 1 show up on the right side. And then if you, for example, wanted to know how many people am I following, like you wanted to know that number. Well, now all you have to do is just check, okay, how many times do you show up on the left side? So if I wanted to know how many people is Kevin following, would just be like 1, because he only shows up here once. See? So if you want to know how many people you're following, you count the left side. If you want to know how many people are, if you want to know how many people are following you, you count the right side. See? So the left side is following, or the follower. So the left side is the follower, and then the right side is the follow, if this even is a word, followee. See that? But they're both going to be referencing the same users table, because users are going to be following each other. At least that's the idea. So for the followers, we understand that, okay, we definitely need to have both user IDs. Okay, now we just have to figure out, okay, what should we call them? So you can have something called follower, which is an integer, and this one is referencing users at user ID. And then we have the followee, which is an integer, and this one references users at user ID. You see how this works? Follower and followed. Sure, yeah, let's do that. Follower and followed. There we go. So we should probably call this, is this a good table name? Followers? Following? Follows? I don't know. If you guys can come up with a better name for that table, if you guys think, then by all means. Okay, and then on the flip side, we want to be able to have a block list, right? Create table if not exists. We'll call this blocks. So we can have, you know, this person, the one on the left side, is blocking the one on the right. So we can call this one, what should we call this now? Okay, now I'm lost. This is the hard part, is coming up with names. So what should I call the person on the left? Maybe the left person is the victim, I'm assuming. So I don't know. Maybe I'll just say regular user ID for the person that's trying to do the blocking. And this is gonna reference the user ID. And then I can call this the blocker, I guess, the blocker. And then the blocked. references, users, and user ID. So interestingly, the way we actually create this table now is that you could actually count now how many people you've blocked, and if you wanted to know how many people have blocked you, you could also figure that out. It's a very sad number if it's greater than, 0, but yeah, it happens. Okay, favorites. Table if not exist. Favorites. Favorites. Okay. So the favorites is very simple. You have a user ID, who's an integer, references, users at user ID. So this person wants to favorite or bookmark, a post. So post ID, integer, references, post at, and the post ID. And that's it. I'm not sure, but is there a way to prevent someone from blocking themselves or following themselves? In SQL, I mean. Yes. Yes, we can actually add a constraint to make sure that the follower and the followed are not the same. So we can actually do that. Yes, we can do that. We'll probably do that maybe on Friday or something like that, or later on once we get a little bit closer to this, fixing some stuff. But yes, that is a situation that definitely can happen. You can in fact block yourself, and you can in fact follow yourself, which is kind of odd. Yeah, you can totally do that. Okay, and so with that, okay, so here I just put create a table that stores the tag usages. Create a table that stores the link between a follower and a followed person. Okay, and then here we have create a table to store a blocked user. Okay, and then here we create a table to store a user's favorite post. All right, I think that's about it. So from here, we have now all these tables. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 tables now. Okay, now what do we do? Well, we need to create a database called bidder. And so we already have all the instructions, right? This is kind of our recipe here. This is our recipe. So this is our entire database, right? But we need this to actually exist because right now, if I launch examp, okay, and I start MySQL, okay, there it goes. It's running. If I go into the CLI, okay, if I say show databases, you'll notice that our bidder database doesn't exist. Okay, so we wrote all this down. Now you're thinking, geez, are we gonna type this all out? And the answer is hell no, we're not gonna type this all out. That's insane, right? We're programmers, so we're all about automating stuff. Okay, so we're going to automate that. So how can I have these commands execute into the CLI? It's actually really easy. The way you do it is like this. You say mysql-u. So you log in, right? In this case, I'm just root with no password. That's the default. And I use a left chevron. I'm basically taking the file that I'm going to tell it, which is the schema.sql, and I'm going to inject it. Basically, I'm telling it, hey, I want you to read the following commands. And so hopefully, if I didn't mess anything up, it should just work. I didn't get any errors here. So it looks like it worked. So basically, all of these commands got ran in the SQL CLI. And so now if I go to MySQL-u root, and I go to show databases, you'll notice here that now we have a new database called bidder. So if I run the use command, use bidder, and if I say show tables, you'll notice that we have all of our tables. We have the blocks table, the comments, favorites, followers, posts, tag usage, tags, and users. And if I say, okay, describe to me the users, there you go. These are our fields. We have primary keys. Here, the user ID is a primary key. The username has to be unique. The email, why did we put the email? Yes, we put the email to be unique because logically speaking, it makes no sense to have two accounts be, you cannot create multiple accounts using the same email, so the email has to be unique. Okay, but we can totally change it later on. So in case you decide, oh, I forgot my email, you want to change your email, you could totally do that because our uniqueness is actually coming from the user ID, not the username or the email. So you can, theoretically speaking, you could change your username and your email. The thing that cannot change is the user ID because this is the primary key. Without this, we cannot actually find, you know, this particular user. Okay, so we need to have this. All right, very good. Now I'm gonna do is call drop database bidder. Now it poof, it's gone. If I go show databases, okay, it's gone. It's gone. Now why did I do that? Well, if you're, working on a back-end system, right? You will always be given the schema to build out the entirety of the database, right? You will be given a schema, okay? You need to figure out a way to automate this process to build it. Now, since we're using Node.js, right? We're using Node.js, we need to figure out a way to be like, okay, if the server is first starting up, we have a super strong dependency on MySQL. The database must exist and the tables must exist as well, correct? We have a very strong dependency. So we need to ensure that it actually exists. Hence why we use the if not exists. Now, the last time I tried to do this in the CLI, it was giving me an error just because I forgot the S. See, that's why it's nice to have a place here where it gives you syntax highlighting. Yeah, so I had everything correct except I was missing the S. So you'll notice that we're not going to create a table, a database, if it already exists. If it already exists, it basically skips it. Nothing happens. So create table, you could totally do it without this. The problem ends up happening is like, okay, well, if the table already exists, SQL doesn't know what to do now. Because like, you want me to create this table, but this user's table already exists. I'm going to die now. Okay, so for example, if I rerun the previous command, nothing happens. Nothing happens. But if I run it with, like, for example, this table without that is not exist, something should crash. It'd be like, this table already exists. There we go. Table users already exist. So it's like, what do you want me to do? So it fails here, and because it fails here, all these other ones will not work. They actually don't run. Okay. So if you had some other crazy stuff here, it would not run because it's dying here. So the if not exists just allows you to just say, hey, if the table exists, create it. If not, skip it. Whatever. Okay. So now I gotta go back in here. Gotta delete it. Databases. And to make sure it's gone. It's gone. All right, cool. All right, now it's gone. So now the next question is, okay, so Kevin, how the heck do we automate this using Node.js? And the answer is very simple. If you paid attention in your CSC60 class, then you should know something about a process, something called exec. when you run an exec command. Okay. Now, again, this is a very Unix-like thing, but Node.js is platform independent, but it uses a lot of the Linux-like commands, or we say POSIX or POSIX. Okay, so what we want to do is we actually want to have a function or somewhere to actually set things up for us. Okay, right now I'm going to just place it here, but later on we're going to move it. Okay, so now I'm just going to say, okay, we have a const. We're going to call this database setup. So it's just going to be just a function that looks like this. Okay, that's it. We need to run an exec command. Okay, so the way you do this, so Node.js has a lot of these things already built in, so we just need to bring one of those modules in. So because I'm only going to use it in this scope, I'm just going to I'm going to bring in that module in this scope. That's a really cool thing about Node.js using common JS modules, is I can just say const, and I'll just bring it in. So it's called exec is equal to require. So I'm going to bring in the module under something called child process. That's where the module is called, child process. But specifically, we want the exec. We want to run the exec command here. Okay, very cool. Now, the exec command is going to allow us to, again, run a command. Okay, it's going to allow us to run a command. And then we will, it's going to try and run it. So basically, if you think about it, it's just going to it's going to open up a shell, and it's going to try and run something. And that's basically it. It's just going to run the commands that you want. So for example, let's try this. Let's do exec. Okay, what's the command? Let's do an ls command. Callback. So we have an error. So we have the error. We have something called the std out. So standard out. And then we have the standard error. Okay. So if the error object exists, okay, then we know that there was an error. So console error, an error happened. If the std error object, okay, so let's say, so this first error is going to happen if something with the exec function went wrong. Okay, like something exploded. I don't know. The module broke. I don't know. This error, the standard error output, is going to happen if when you ran the command, something else went wrong. For example, let's say you ran MySQL, but you didn't feed it a username, or you gave it a username, but it was the wrong username. That's going to throw an error. So it wasn't that the exec failed to run, it was that the command ran correctly, but the command itself threw an error because you probably fed it some wrong information. So there's the std error. Okay, we should probably do a return. So with these ones, I usually just do a return here. Just do a return. These errors just return undefined. So this is just a shorthand. Okay. And if everything else went fine, then it went fine. So we can just say, something like, okay, std out dot, yeah, so this should be just be a string, right? Yeah, it should just be a string. There you go. So we'll just do a console.log std out. So this is a standard output, right? This is like, so if I run an ls command here in the console, the string that you see here is just the std out, right? The standard output. Okay. All right. So let me comment this out right here. And then let me just run this database setup. Okay. Now, right now, I'm just running an ls command. So let's see how this works. So I'm going to say node index.js, and there you go. Right? This basically is telling us, right, what's in this current directory. Because I just did an ls, which is in Linux environment, is just listing. So you see I have the data requirements, I have the index, the node modules, etc., etc. So this is just listing out everything here. What's another thing we can do? Another command called uname. Uname is a POSIX command that basically tells you what the name of your environment is. So mine's minwig64. Okay, that's cool. We could do something like echo hi. So we're just going to run an echo command, just say hi. So now it just says hi. It literally echoed hi. So there you go. Okay, cool. Very cool. And that's all an exec does. Very, very simple. So how can we leverage this to automate this command, mysql-u root, and then feeding it in the schema? How can we automate this? Well, I just showed you how. You just type it in here, mysql-u root, go like that, and then schema.sql. Okay, now we run node, Node.js, and we got nothing. We logged this out, we got literally nothing. Because remember, with MySQL, if you feed it the file and everything ran okay, you get nothing. You literally get nothing back. But if you mess something up, for example, if you remove like if I try to create a database, but it already exists, so I don't do the is not exist. If I run this now, we should get an error. Boom. Command failed. There you go. And this is not coming from the MySQL. This is coming from Node.js. We caught the error right here, right? So you can tell which error it comes from. Console.log error, and then here's console.log, and then std error. Okay, so let's run this again, so we know where it's coming from. Okay, in this case, it's coming from error. So this one just literally threw an error straight from here. It didn't even want to come here. That's funny. I wonder if we flip these around. I don't even think std. Oh, there you go. So we're getting two different things. So this is coming from the actual MySQL, which is what we actually saw in the console when we ran it, and then this is just like a whole throws. So I think it'd probably be better that you use this instead. So flip them around. So I think this is probably a better route to go. Okay. All right. So now that we have that out of the way, let me put that back. So now we have a way to automate this. Beautiful. Beautiful. Now, what is the problem here? The problem is, okay, what happens if an error occurs? Right? What happens if an error occurs? Okay? We have this app.listen, right? So if I were to run this and this throws an error, okay, this will keep going. That's the problem, is it'll keep going. So let's force that error to happen. So let's say I messed up. Instead of schema, it just said, schema. There you go. Now I run this. Error, the system cannot find the file specified. Hey, but we're listening on port 5050. Well, that doesn't help us, right? Because we need this thing to die, right? There's no point in having your backend up and running if you can't even connect to your database. This whole thing needs to die. Okay, so I'm going to kill it right here. Okay. So you might be thinking, okay, so should I run this database setup and then do I run this? So should I move this in here, for example, like this? Should I run it like that? So we run our exec and then do it like this? Like, what should we do here? And again, this is, different strokes for different folks, however you want to solve this problem. I feel it's best to solve it using something called promises. So this is the way I like to solve this problem. So the issue that we have here, unfortunately, is remember this exec is going to probably take some time. We have no idea how long it's going to take to run. Okay, we have no idea how long it'll take. Okay. So if I were to do something like console.log exec here, so let me comment that out. When I run this, it's possible that this runs before this, right? Because this could have some overhead. Remember, we're creating a whole new process here. So it's possible we get exec. Yeah, see, we're getting exec first. So this got called before this even got a chance to run. The inside even got a chance to run. So, we have this thing where it's just like, okay, we need to now wait until database setup has completed, right? We need to wait. So how can we wait in Node.js to wait for some function to finish doing its thing? And that's using something called, asynchronous code, right? We need to do something called we need to do something asynchronously, because that's essentially what this is doing. This is doing something asynchronously. It's going to spin up a process using this command, and then it's going to hook you in and let you know about any possible errors that popped up. So again, when it does this, it's not going to be instantaneous. So that's why we saw this console log pop up before any of this, even though this came before that. Okay, because this is going to take some time. So how can we wait? How can we wait? So the best way to do this is to have this function become asynchronous. Okay, now we can wait on it. We can actually wait on it now. Now we can say, okay, let's try and do the database setup first before we do anything else. So we can actually wait. Okay. But how do you wait on this? There's no way this exec is not asynchronous. It is asynchronous because we have this callback function, but there's no way for us to, use await. Like you can't do this. Like you can't, what are you awaiting? Because this is not an awaitable function. So how can we convert this to be an awaitable? That's where promises come in handy. So here we're going to create a promise ourselves. So we say const. We're going to call this MySQL command cmd is equal to new promise. Okay, this is a promise. So this promise in its constructor takes in something called an executor. Okay, it takes an executor. Okay, so the executor is just a function. The function, when the promise gets invoked, it's going to allow you to run your code. Okay, it's going to give you two functions that you can call. Okay, and it's going to wait for you to call them in order for the promise to be resolved. The first function it gives you, and it's passing these as parameters, is something called resolve. The next one is reject. Okay, so let me blow this up a little bit. So now we're creating a promise object. The promise takes in a function. It's going to feed you two functions, one called resolve and one called reject. If everything goes well, you invoke resolve, and then you can feed it any parameters that you want. It's up to you. It doesn't care. If something goes wrong, then you call reject, and you can give it a reason. For example, you could just either straight up reject it, or you can give it an error message or something. It's usually best to feed it an error object. Okay, and then if we hover over this MySQL command, you notice that this MySQL command is a type of promise. Okay. Now, this function here is going to allow us to run some code. So this promise knows you're going to take some time. That's kind of the whole point. This object, if you want to think about it, is a wrapper for a thread. Now, I'm using that super loosely. It's not a real thread. Okay, it's just a way to halt a function before it moves on to the next command. It lets you stay there until, this asynchronous task gets resolved, which we know can take some time, right? I proved it to you by showing you an example that this logged before this, okay? Okay, so all we have to do now is just push this code up inside of the promise, right? That's it. Now that we have this, okay, now that we have it like this, so we pushed our exec code inside of this function here, this arrow function. Now we have the resolve and reject. Okay, well, how do we reject something? Like, we have two ways to reject something. You have these two errors, okay? So if we have this error, we will call reject. Okay, we'll say new error, and this error takes in a message. So let's just feed it that message, because remember, the std error is just a straight up string. So let's just create a new error and just pass in that string. Okay, we're done. That's it. We rejected it, and we passed it a new error. Okay, done. What about this one? Well, this is an error object. See that? This is an exception. So we can just say reject and just throw in that error inside, because this is this exception is already an exception type. So it's a type of error. So we can just throw that error in there. Okay, cool, we're done. Now we have a way to kill this promise, right? We have a way to reject it. What about resolving? Well, if we have these two if statements that can possibly tell us that, hey, our this command here, you know, something went wrong. But we know that if these two things are empty or null, then it looks like our command ran just fine. So in that case, we resolve. We just call resolve. Do you want to send a message back? That's up to you, right? That's up to you. It's literally up to you. In our case, we just want to know, did it work? That's it. That's all we want to know. Did it work? So in this case, we're not going to pass anything. We will be doing more of these. So this is not going to be the last time you see this. Okay? So don't trip out if you're like, oh, I want to see an example of you passing in something to the resolve. We will be doing that. But this is just your first introduction into promises. So in an interview, if you ever have to do something where like there's possibility that something could take a while, the first thing you should think about is using promises. Okay? That shows you that you know how to work with asynchronous code. And that is a huge booster in your interview. It's like, oh shit, this person knows how to write asynchronous code. You know, he's seen a thing, he or she has seen a thing or two, right? This programmer knows what they're doing. Okay. Most people haven't used this, you know, so, you know, this is more of an intermediate level, I would say. So there you go. Okay, so now that we have a promise, what the hell do we do with this command? Well, you just call await. We await for this MySQL command to resolve. And that's all you have to do. You just await it. You don't do anything else. And that's it. Just await it. Okay. Now, we say const, we can actually capture the result. The problem is that the result is not going to be anything, because we're not returning anything. We're not, you know, there's nothing in here. JavaScript is smart enough to figure out, like, let's say we say hi, that this result, no, it still doesn't know. Okay. I thought the JavaScript would actually be smart enough. I guess it didn't figure it out. Okay. Cool. So now we just say await MySQL command. Okay. So let me comment that out. Okay. And so now we should get the error, and then we'll get exec, maybe? Well, let's see what happens, because we know that this is an error because I'm missing the S in there. So let's see what happens now. All right, we got this huge error, bigger than before. So let's see what happens. So it says, okay, yeah, the system. But notice here, there's a difference now. Notice here's a huge difference. Notice that exec didn't pop up over here. Remember before it did? Because this took some time. So it said exec, and then it would show the error. Now it's not. That's not the case anymore. Now we're getting the error before we even see exec. In fact, it died here, so we never got to see exec. Now, why is it dying? It said right here, unhandled promise rejection warning error. The system cannot find the file specified. That was the rejection that we threw in here. Now, if you continue reading, it shows here that unhandled promise rejection warning, unhandled promise rejection. This error originated either by throwing inside of an async function without a catch block or by rejecting a promise which was not handled with a .catch. To terminate the node process on unhandled promise rejection, use the CLI flag, blah, 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 blah. And it's right here, unhandled promise rejections are deprecated. In the future, promise rejections that are not handled will terminate the Node.js process with a non-zero exit code. So what the hell does that mean? It's the same thing when you're working with Java, right? If you're working with Java, if you try to open a file, that entire function needs to have a throw attribute attached to the method, or you need to have that specific code inside of a try catch block. Okay, so in Java, if you try to do any kind of IO operation, for example, or any kind of operation that could throw, so specifically IO API calls, Java is going to force you to either decorate the method as throws exception, or you have to wrap that piece of code around a try catch. Now it's complaining because obviously this thing had an error. We rejected it, but nobody caught it. So this entire thing crashed. So what Node is telling you is, hey, don't be doing that. If you know you're going to be awaiting something and you could get rejected, try and catch it. So if we just happen to just wrap this around a try catch block like this. Okay, remember there are no types, so your catch is just E. Okay, then we're good to go, right? Here we just say console.log E, right? We just log E, whatever the heck E was. Now we're going to run it again, and we're not going to get that big old error. There we go. Now it just says std error, because it died here, and then we see exec. You see the difference now? So instead of it being the other way around, exec happens last. See, I haven't even touched this because we awaited, because we knew that this thing was going to take some time. So using some asynchronous code, we were able to await this promise. See? See how it works? Because we knew that this is going to take some time. So we wanted this function to halt right here and wait until this code finished, specifically this exec command. And it's asynchronous because we have this callback. Now, at the time when Node.js was first being built, they chose to use callbacks because Promise API was not a thing. I think it was still in development. So they chose to not use promises. They didn't really understand how to use them, and they weren't entirely sure the API wasn't supported on all browsers. So they decided to go through this callback way. But now that we have promises, there's going to be a lot of situations where there's some Node.js modules that have these callbacks, but we want to have them asynchronously, so you have to wrap them around a promise. Now, if you use something like Deno, which is by the same creator of Node.js, Deno uses TypeScript by default, and all functions use promises. Anything that's going to be asynchronous, instead of having callbacks, they are now all using promises. So moving forward, you should think about using promises everywhere in your code where you know something's going to take a little bit of time. All right, so now that we have this, how do we use this in conjunction with our app listen? Because we only want to listen if it's the case that this ran just fine, right? We just wanted to run only when it ran just fine. Okay. So here's the problem. This is an async. Asyncs, if you hover over database setup, what is the type now? This is a type of what? It's a type of promise. So async is just syntax sugar for this. eventually this async is going to get replaced by a promise, and it's going to wrap this entire thing around one of these. So this async is just syntax sugar. This becomes this, because if you notice, database setup is a type of promise. So every time you see async, it's just a shorthand for this. It's just syntax sugar. That's all it is. It's just syntax sugar. So why did I bring that up? Well, should we be trying and catching here? Because now we know that this will never crash because we handle the error internally. So the question should now be is, should we catch the error here, or should we leave it as is and then catch the error out here? See the difference? See, because if we do it the other way where we catch the error internally, then technically, because you already handled the error, this technically executed just fine. It executed successfully. Even though internally the function technically crashed, but since we caught the error, everything went fine. See the problem? So there's a couple of ways to handle this. One, don't catch the error and catch it out here. Whoever's going to call this function, we know that this thing could possibly crash because it's a promise. Promises have the ability to get rejected. So if in case it gets rejected, you need to then handle it. So if we run this now, we should get the exact same error. Okay. Oh, it didn't like it because we have this promise. Okay, so it doesn't like it. So it's going to force us then to do this. It wants us to do this because we're inside of a, oops. It's forcing us to do this because we're technically inside of a promise, and the promise needs a way to get rejected. And so, yeah, okay. So, okay, so now we are essentially stuck again. So now we have to figure out, okay, so now how do we reject now? Well, if we are in here, you could technically just throw new exception. Oops. New error. Failed to set up database. Okay. And now if you run this, we're going to get this thing, and then we're going to get this error, but this one handled just fine. We now need to handle this one. So now we have two throws. Push that up here. Now we got to catch this one. And what is happening here? Failed to set up database. It really doesn't like it, huh? Oh, right. I think we need to await it since this is a asynchronous thing. There we go. No. Oh, yeah. And then we're in a situation again because so Node.js brought in asynchronous later on. And so what we call it the global scope cannot be asynchronous. So our global scope here, we cannot use the word await. You notice that here we're technically in the global scope, right? Global scope. We're not inside of a function, therefore we're in the global scope. Because we're in the global scope of this file, we cannot use await. We have to wrap everything around. We have to put everything inside of a function, or we do something like database setup. dot then. We catch it like this, which this is not going to do anything, but we also have a catch. So this catch is going to give us our reason. So because I cannot use await, this is my only other option, which is similar to this try and catch. So if everything goes well, then we say console.log database setup success. But if something went wrong, we can throw that reason in there. Okay, we cannot use await, so we're stuck using callbacks using the then and the catch. So if we run this, we should be fine now. See, now it just says failed to set up database, and it tells us where it caught that error, because I said error. If I do a log, we're not going to get all this fancy schmancy stuff. Oh, it still doesn't. Okay, whatever. All right, so we get that failed to, oh yes, because I threw an error. Because I threw, it does that. Okay. All right, so now we have this. So now that we are in this situation, now we know, okay, well, if the database setup went well, what can we then do? Well, in the off chance that it, in the off chance that it actually went well, what should we do? Database success, actually run our application now, because now we have our database, right? So if we just do this now, add the actual S to prevent the error. So now we have a valid command. Now if we run this, it's going to say database setup success, and then it should say listening on port blah. And we say exec database setup success, listening on port 5050. Boom. Now we have our database setup happening before we even have our Express application even running, right? So here I'm going to remove this because we don't really need that. Let's run this again. Dang it. Okay, node index. And there we go. We can remove exec now too. So let's remove that, kill this. All right, now it says database setup success, listening on port 5050. Now we are only running our Express application if and only if the database setup has succeeded. Do you see the difference? Do you see the difference now? So let me know if anybody has any questions about this, because this part's really important. We have to set up our database to make sure that it exists. All the database actually exists. All of our tables are there. Then, only then, can we start up our Express application, because there's no reason to have your Express application if you have no database. All right. So now that we have that out of the way, we have multiple windows here. Then click over here, and then not that one. I want this one. Okay. Cool. Very cool. Now, this little command here is going to give us a problem later on. I'm not going to talk about that right now, but we'll see it in action on Friday. Okay, so the next thing I wanted to talk about is something called a service layer. Okay, so Jim Bob's asking, wouldn't we set up our database separately in a deployed app? Is that something we let Express handle for us? So yes, so our database is set up separately, right? So again, this can be any number of things, right? This can be literally any number of things. Right now, we don't even have a connection to MySQL. All we're trying to do is say, hey, in our local environment, right, make sure that the database schema has run at least once, so we know the table exists or the database exists and the tables. Okay, you're 100% right. Shouldn't it live somewhere else? 100%. However, you will still be given something like this. and you still need to deploy it. How do you deploy it? Are you going to run all of this commands one by one? No. I just showed you how you can automate that process. This works in Linux. So if you were using like AWS and you had a Ubuntu server and you guys were controlling the database that way instead of using RDS, I just showed you how you could do it. So this is totally usable in the real world. But yes, ideally your database should live on a completely different machine. So if your server dies, your database doesn't die. It still lives. Okay. We will update this to actually, once we run this, we want to also establish a connection with our SQL database. That connection is what you want to know as well. The connection can take some time to actually be done. So if we cannot establish a connection with our database, we should not have our Express application run. So notice how I call it database setup and not database create. I just call it setup. In our scenario, we have to make sure that the schema has actually run at least once, so we know that the database and the table exist. If all of that stuff has already been done separately, you deployed it on a separate machine on the other side of the world, then yeah, maybe you don't need to run this, but you still need to establish a connection, and then you need to make sure that the connection is valid. So the next step is for us to actually create a connection, which is actually what we're going to do right now. And that is, we need to talk about something called service, a service layer. That's actually, I think that's in the title of our talk today, is something called a service layer. Yes, a service layer. And we kind of talked about it a little bit before, like last week, I think, talked about it a little bit. But now we're going to actually structure our project to allow for such structured, project. So the first thing we want to do is we want to create a folder here called services. Okay. And then we want to create another folder in the root. We're going to call these things routes. These are going to be our various routes. You can think of the routes as your slash whatever, slash users, slash post, slash whatever. Those are your routes, right? Those are going to be your routes. And I think that's it. That's about it. Okay. So we have this. We have our routes, and then we have our services. Okay. So inside of our services, we're going to have a few services. So essentially, we need to have a service for every single table. Right? We need to have a service for every single table. Now you can have a gigantic you can have a service that is made up of multiple services. You could do that. Now, what the heck is a service layer? Right? The service layer. The service layer is basically a middleman. Okay, it's an abstraction between the piece of software, the class or whatever, that is trying to consume data and trying to give you data. Right? So the service layer will take data in as input, whatever that may be, or even just a request. And then the service layer will then go out to the data layers, for example, MySQL, and then extract the data on your behalf, right? So it's a person that does it in the middle. Then the service layer could also add some business logic and can transform the data. So in MySQL, for example, if we do a query for the data, in a traditional sense, we always get rows. We get a row of data. That is meaningless to us. That doesn't help us. We just get a row of data. We need the data to be in a specific format. For example, we are trying to build a RESTful API. That means that, and it doesn't have to be this case, but in our case, we want the data to always be in a JSON format. So we need the service layer to do a query on our behalf to our MySQL database, extract the data, and then format it properly. Okay? And then give us the data. in a correct format. Okay, so that's what the services is supposed to be. Now, you might think I'm over engineering it here at this point, but I don't think I am. The over engineered section here that I'm trying to talk about is that we should have our service layers should be abstract. They should have no implementation because the actual data layers, we don't know where the data is coming from. Okay, our services should not know exactly where they're coming from. So we need to have an interface. Unfortunately, JavaScript does not have a concept of interfaces. It doesn't have, so you cannot have a class that inherits from multiple classes or something like that. Like that's not possible. If you have TypeScript, you can have interfaces, yes. In JavaScript, vanilla JavaScript, there is no way. So we have to, kind of figure things out how we can actually build this. So the way I like to do this is I just create a class. So we can call this like base service.js. And this is just going to be a class. I'm going to call this base service. And then this base service is very simple. Okay. It's not going to have a constructor. All it's going to have is one method, init. That's it. This init needs to, since we cannot have an abstract tag because we're not using TypeScript or anything like that, we need to make sure that this init, that whoever inherits from this knows that this needs to return a specific type. So how do we do that? We can use the JS docs like this. So when you have, so let me do that again. You can do a /** and then hit enter. Okay, and this is the format you want. JS doc is a way for you to document your JavaScript code. Remember, there are no types in JavaScript. So how can we add typings to our JavaScript if there are no types? Well, you use JS docs. They're basically very advanced comments. So one of the what we call annotations that we can use. So annotations begin with an @. So one of the annotations we can do is one called a return. So returns what? So this method returns what? So what's the data type? So you do a space, and you can insert the data types inside of curly braces. So you notice that they have a special color now. So if you do control space, you'll actually get different types. So what we actually want to do is we want to say, oh, this is a promise. Now a promise, as you can see here, is an interface. This is using the TypeScript typing. That's why we have these, interface. But this only exists in TypeScript. Okay, so this promise, you see this is a generic type. Basically, it's like, okay, we have a promise. Promises can return something. So what should this init return? We just want to say this is a void returning. So this promise doesn't return anything. Okay, and that's it. That's literally it. Our base service just does that. Now, again, we're using CommonJS or the Node.js, whatever. So we have to do a module.exports is equal to base service. We need to export this class out to outside of this file. Else, because modules isolate themselves, so we need to manually export them out if we want to be able to use them somewhere else. Okay, now that we have a base service, now we want to create a service that can actually use it. For example, we have a users service.js. So we're going to say const base service is equal to require /. So the // means go into my current directory, and there it is, base service. Boom. We have a base service. Then we're going to create a class called users service. This user service is going to handle how we can create users, how we can update users, how we can find users, etc., etc., etc. That's going to be the job of this class. And so this user service needs to extend, so it extends base service. And so the user service is just going to be a bunch of CRUD operations. That's all it is. And so before we forget, let's do a module.exports is equal to user service. So what do we want to be able to do? Well, we want to be able to create a user. So we want to have a method that creates a user. Again, we're not going to have anything in here, right? It's supposed to be an abstract. This user service is supposed to be an abstract class, but there is no concept of abstract classes in JavaScript. We need something like TypeScript to do that for us. Okay. So now we're using JSDoc to add some functionality here. So if we create a user, we want to be able to return something. We want to be able to return a new user because we created something, right? So if we have this service, and remember the service has to go out into the database and be like, hey, I would like to populate a record into your table. Remember, that's going to take some time. So right off the bat, you should already know that create user should be a type of promise. So we need to return a promise saying, and in the future, we will resolve this. Now, the question is, what should the promise return? The promise should return something called a user, right? That's an object, our user object. Which our user object contains what? A user ID, the username. Technically, it includes the password, but remember, the user service should do what? It should add some business logic to prevent things like the password from leaking out. So we do not want the password, right? We want to get the first name, the last name, the email, and the number of followers. Okay. So how can we create a user? So we can use a class, or what we can do is at the very top is what I like to do. At the very top here, I like to create a comment up here, and I do something called a type def. So I'm going to create this type, this user's type. I'm going to create it manually. Okay. So the way the type def works is you need to say, okay, well, what is the overarching type? Okay, what is the overarching type? In this case, it's an object. Okay, it's going to be a JavaScript object. Okay, again, this is just one of the downfalls of JavaScript, which is why you should be using TypeScript and not JavaScript. But hey, we're using JavaScript right now, so let's get to it. All right, so the overarching type is going to be an object. Now, what do we want to call this? We're going to call this a user. So that's what it's going to be called. That's the type. So this type actually exists now. So if I go over here into my little chevrons and I hit Control Space, hey, look, there's a user now because it came from here. I could call this tuna. I go over here between the chevrons, Control Space. There it is. It's tuna, right? This is my user. So this promise wants to return a user. When we create a user, we need to feed it some information in order to hopefully, there's no guarantee that we'll actually get a user back. We hope, fingers crossed, that we actually do get a user back. So how could creating a user fail? Well, what happens if you have a username, you're trying to use a username that already exists? Well, it should fail. Well, what happens if you try to use an email that has already been registered with another user? Well, it should fail, right? So there's definitely a bunch of ways that creating a user could actually fail. So there is no guarantee that a user is going to come back. The problem here is that we actually are guaranteeing that a user is going to come back. That's what this promise is doing. Now, remember, we can also reject, right? But we'll come back to that. And I want you to think why I think that this is not the correct way of doing it. Okay, but let's continue with this part. All right, so now I have my type def. Now, I want to create a JavaScript object. So remember, a JavaScript object is just an object with properties. So I want to add exactly that, a property. Okay, what should be the type of this property? Well, my user ID, it's under user ID, oops, it's a type of number. This is called user ID. That's where it comes from, right? That's our user ID. Next, we want to add another property. The other property is going to be our username. Oh, I'm sorry. This is going to be a string. This is our username. We have another property that is going to be, we don't want the password. So we skip the password. I believe we called it fname. So we have, dang, I keep putting it in the wrong place. This is going to be a string, and this is called fname. String lname. So we have first name, last name, add property, string, email, and then add property, and then let me double check here. I should probably be going off of this. So yeah, okay, so we don't have the number of followers here. We're gonna calculate this using a query. All right, so that's it. Okay, cool. Now, let me ask you a question. Okay, when we create a user, what is the data that we can actually use in order to create a user? Well, it's all of this except this, right? Because who's going to generate the user ID? The backend. More specifically, it's going to be the database. It's going to generate these IDs for us. Again, you don't have to do that, right? We could actually generate them ourselves and then just store them into the database. But in our case, we're going to use the database to actually generate these for us using the auto increment. So when you create a user, what is that supposed to look like? Well, you got to feed it a username, first name, the last name, and an email, and then also a password, right? You need to have a password associated with it. Okay, so this is getting to be kind of a problem because we cannot fill all of this thing, we cannot satisfy all this stuff. Okay, so what we need to do is create something called a DTO. That is a data transfer object. A data transfer object is just a subset of the object that it's supposed to represent. That's all a DTO is. Okay? So we need to create that. So here, we're going to create another type def. What is the overarching type? It's an object. We're going to call this user DTO. User data transfer object. So what's the thing that you can give us? What is a subtype? Well, it's basically all of this. Okay, it's all of that. Because later on, when we try to update, let's say we want to update the first name and the last name. Okay, if we try to update the first and the last name, yeah, sure, we need the user ID, but for example, if we try to create a user, we don't have a user ID. This is the very first time, right? We're creating a user. So how can you know the user ID? You know, it's like putting the horse before the carriage. That doesn't make any sense. So we need to have a subset. Now, it's possible that we can also have a password in here. Okay. You can have extra properties and they're not going to be in the final object because these ones should not be coming in. Okay, this should not be happening. We're going to have very special queries where we can figure out the password and then we can try and compare to make sure that, you know, when it comes to validation or specifically authentication, we can do stuff like that. The user DTO could have it, but most likely than not, it won't have it most of the time. The only time you're ever going to have a password in a DTO is when you first create it. So what we mean by a DTO is that there is no guarantee that all these fields are actually going to exist. Because when we try to update something, what if you just want to update the first name? Why would you give me all the other information? It makes no sense. So a DTO is just going to be a subset of the username. Mostly. The password though is going to be like an exception to the rule. We could also have a sequence where we have the password be a separate thing. That's also a possibility we can do. Okay. So there's our DTO. There's our user and there's our DTO. So when we create a user, we need to have the user DTO in here. So how can I create a type for this? All you have to do is say at param, and this goes in order. This is going to be a user DTO. What is it called? User DTO. That's what this one is. So if I were to just remove this, if you already knew, oh, I want to pass a user DTO, if you do a // it's smart enough to know it picked up a parameter. Hey, there's this user DTO. It put it right here. But it doesn't know the type. The type for any is just an asterisk, or you can be more specific and say any, right? By default, JavaScript just defaults to any. In the typing here, you could use a star if you want, but we know what this is. It's a user DTO. Okay. And again, by default, because we have no return, the JS doc was not able to figure out what you were trying to return. Okay. If we return something like a string, like hello, right? If we do it again, it will actually figure out, hey, we are returning something. I can't really figure out what you're returning, but I do know that you're returning something. So in this case, it's not able to figure out that we're trying to return something, unfortunately, because we haven't said a return yet, because we're trying to mimic an abstract class here. Okay, so we have this one. So we have a param as a type of user DTO. And what's really cool about doing it this way is now if I say user DTO dot, I get all the properties here. Look at that. I get all the properties. That's cool. Versus if I don't do this, so if I remove this, you probably have seen this before, where you say user whatever, and then it's like, you don't get any IntelliSense, because it doesn't know the type. It doesn't know the type. But now using JSDoc, we can actually type things, even though, you know, technically JavaScript has no types. But we're adding annotations around it to act like we have types. Okay, cool. So now we have a way to create a user, and we know we're going to return. How much time do I have left? Ooh, I'm over time. Damn it. Okay. I really want to get through this. Hopefully, if you guys want to stick around to 8 o'clock, feel free. If not, you guys are free to go. I'm gonna keep going to 8 o'clock because we just don't have enough time. I want to get through the rest of this. So if you guys are okay with that, we can go to 8. If not, we'll call it a day. What do you guys think? Should we wait till Friday, or just keep going? Jim says he's good. All right. Well, if at least one person's going to stay, then I'll keep going. All right. So we have a way to create a user. So we have a way to create a user. Next, we need to have a way to, well, if you create a user, we need to be able to delete a user. So we need to be able to delete them via their user ID. So user ID. Okay. So we're going to use our JSDoc annotations. Notice that it picked up that, hey, you have a user ID. We know that this has to be a number. Okay, and we also know that when we try to go to the database to try and delete it, it can take some time. So we're going to return a promise. And then for now, we'll just do something like, we'll return a Boolean, whether it got deleted or not. So true or false. Okay, so you can do something like that. So delete user, true or false. Did it succeed or not succeed? Right, that's about it. Now again, this is terrible because we don't even have any kind of tokens. How do we know that whoever initiated this command to delete the user actually has proper permission, right? So we don't have any of that. So you gotta keep that in mind. So we have create user, delete user. We want to be able to update a user. So here's the user ID. We need to know the user ID, and then here's the user DTO again. It's going to have the data, whatever it is that you're trying to update on the user. So again, using the JS doc, it figured out, okay, cool. You have a user ID, but it doesn't know the type, so we're going to tell it, hey, this is a number. This is a user data transfer object. Remember that. It's a data transfer object. And again, when you update the user, you're going to hit a database, and that can take some time. So we're going to say, hey, this returns a type of promise. And if everything succeeded, you should get a user back with the all new information. If you change the password, you'll just get the same user again. So maybe you should. It's better that you have a different subroutine for changing passwords because that should be cryptographically safe. Okay, so we have a way to create a user, delete a user. We have a way to update a user, but now we need to have a way to find a user, get a user. So get user. And we can do things by like user ID, for example. So I have a number here. There you go. So if we get a user, right, it's in the word get. So what should we expect to return? Again, to get a user, it's going to take us some time. So we got to use a promise. In the chevrons, what's the return type? Well, we're trying to look for a user, so we're going to get a user. Okay. And then as an added bonus, we'll just do get all users, though this is terrible. Don't ever actually do this in production. Because if you have 1 billion users, Jesus Christ, this is not going to look good. All right, so at return, so this takes no parameters, but it's going to return what? It's going to return a promise of what, though? It's going to return a promise of an array of what? Of user. So this promise is going to return an array, and the array, remember, an array is a generic type. See that T? It's generic. So what is the type of array? Well, in this case, each element will be a type of user. So again, this is terrible. Okay, but for our case, we're going to have a small amount of users. This is fine. But you will never see this in real life. There will be no API to get all the users. At least not in this form. This is very naive and dangerous. Your payload will be super large. You would want to break it up into like segments, like get me all the users in this region, and then do some kind of like cursor operation where you only get the first 50 and then you have a cursor so you can enumerate your way through. This right here is too naive. It's going to return everything. We're just going to do this for testing purposes, but don't ever do that. All right, that's one user service. Cool. So now we have this API. Doesn't do anything because it's supposed to be abstract. Okay, now we're going to create a folder here called MySQL. So this is going to be a services that are going to basically so in this folder is going to be services that are based off MySQL. So in here we're going to have a MySQL user service.js. Okay, so what do we need to have? Well, we're going to basically implement all of these things. But first, we need a couple things. So first, we need the user service. So users service is equal to require dot slash. We need to move up one directory because we're in the folder, right? We need to go up one directory. So dot slash, and there's our user service. So now we're going to create a class called MySQL users service. We're going to extend the user service. Now if I hit Control Space, look at that. I have all of the methods from user service. All I have to do now is implement them. Okay. MySQL, however, needs something very specific. You need a connection to MySQL, or else the service doesn't work. So how do we do that? Well, we need something called a dependency. So we're going to create a constructor. And in here, we're going to have something called a connection. Okay. Now, in MySQL, in JavaScript, if you think about this, looks kind of like a Java class, right? So in Java, you'd be like, oh, if you were in Java, you'd probably say something like, oh, private, SQL connection, connection, and over here you would say something like, okay, this dot connection is equal to connection. You would probably do something like that. That doesn't exist in JavaScript, right? So you can't actually declare fields like that. You can't do that. So how do you do it? You just say this dot connection, you create the variable on the fly, and then you just do it. So this dot connection is equal to connection. The problem is that, I'll show you an example here. So I'm going to say just instance is equal to new. So if you had an instance dot, now you'll notice that connection is public. That connection should be private. It's a private object that it should not be allowed to be seen on the outside world. Okay. So how can we hide it? Well, we can hide it by adding an annotation. We say at private. That's it. Now this is private. So I say dot. Notice that you don't see instance anymore. It's private now. Ain't that something? Right? Okay. So now that we have this thing to be private, the connection is still a type of any. Notice that the type is any. See that? It's any. But what is this connection supposed to be? It's supposed to be a type of connection. So let me annotate the parameter here. This is a type of connection. Now you'll notice that when I type in connection, it's saying, hey, are you talking about MySQL? And the answer is yes, I am talking about MySQL. And the reason why I was able to pick that up is because, remember, in the previous session, we had already installed MySQL. So if you haven't installed MySQL, you're not going to get this annotation. But now that we have that, notice that I created this variable called connection, and I'm setting it equal to this connection right here. That's why I use the keyword this. This connection, however, is still a type of any, but if I hover over connection, it's a type of connection. So how can I make this be a type of connection as well? Well, all you have to do is say at type connection. Now this is a type of, look at that, it's a type of connection. Done. Now I can do things like this dot connection dot, look at how all my dots in here. So I can run like a query, and now we can start doing some queries. Oh shit, oh shit, oh shit. It's happening. So before we forget, we do module.exports is equal to MySQL service. Okay. So this dependency, this connection has to come from the outside world. Hint, hint, it's going to come from our setup. Okay. All right. So let's implement create user. So create user needs to have a DTO. We have this user DTO. Okay. So notice it says user DTO over here. Okay. Boom. There you go. Import, and it does it all for you. Cool. And then remember, we're going to return a promise, which is a type of user. And again, this is coming from the user service. So that's how it's importing it like that. Beautiful. So now we have this user DTO. So if I say user DTO dot, I have all the information. So this, again, this is under the assumption that they hit the API. The API is now doing a request to the service and saying, hey, here's all the data that I got from the web, from the internet. Somebody made a request, and this is the data they gave me. Now, it's this method's job from this service to then communicate with the database and try and insert it. Okay, remember, for creation, if we go to our SQL commands here, if you're trying to add a record into a table, you need to follow this. Insert into the table and then the various fields. Okay, so I'm going to put this over here so we can see. Now, how do we do that? How do we do it? Well, here's our MySQL connection. Right? We have a way to have, we have a connection now. This is under the assumption that we have a connection. Okay, so we have a connection. What do we do now? We do a query. We run a query. Beautiful. Now this query takes in a query object. So we start by doing this. Now this query object has something called SQL. This is going to be the string, the SQL string. Okay, remember, in JavaScript, objects are just JavaScript objects. Okay, let me zoom in a little bit over here. So notice we have query, and it's just a JavaScript object with a property here called SQL. And this is going to be your SQL command. So we're going to say, I'm just going to follow this right here. Insert into, the table is users. What do I need to insert? Well, now I got to remember the shape of it. So I'm gonna click over here and then double click the schema, so it pops up on my right. So here now I just gotta follow this. So what are we inserting? Okay, the user ID we do not insert because it's a primary key. Okay, this will get generated automatically, so we don't pass that in. So what are we doing? So we have the double check to make sure I am. Whoops, got a phone call. Sorry about that. Hopefully that didn't blow up your ears. Double check here. Okay. So we don't have to do this. Okay, so we have user name, f name. I'm just labeling the columns. Username, f name, l name, and email. So actually these ones should have a like that, because these are the column names, right? So we have username, f name, l name, email. Then we have password. Okay, so those are all our fields. Then we're going to put in the values. Remember the SQL command. We specify the field names, and now we have the values. So the values is going to be, and then with semicolons, the values, we pass it now one at a time. Okay. So we have all our values from this DTL. How do we put them inside of here? So what you could do is you could make this into a string literal using the backticks, and then you can just inject the values in here like this. So you have user DTO dot username, and then comma, do another injection, user DTO dot fname. Again, you have to follow the order in which you typed it out here. You have to follow the order. So if you mess up here, you're screwed. User DTO dot lname, user DTO dot email, and then user DTO dot password. Okay. Okay. Cool. All right. And so once you do the query, you have the option to have a callback here, and it's usually done as a function like this. Function, you have the error, you have the results, and then you have the fields. Oops. Okay. This is how you'll see it in the documentation if you look it up. Though I prefer to do it something like this. I use the arrow function. Okay. And if you hover over error, this error is a MySQL error. The result is any. This result, the reason why it's any is because, well, we don't really know. Because the results, this is what I hate, is it could either be an array or it can be like nothing. So, so we don't really know. And then the fields is just going to be an array of field information. So for this very first part, I think it's best that we just see what it looks like. So we're going to say, we're going to say if, we'll just log everything. So console.log, we'll type in here error, we'll type in the error, console.log, results, console.log, fields, and then fields. Okay, that way you can see what these things are. Okay. Now here's the crazy part. It's like, okay, well that's great and all, but how do we return a user now, right? What was the problem that we had before when we were doing the setup here? This doesn't really return anything, and then this takes some time, right? So how do we fix this? Well, remember, this is technically, it is asynchronous because we have this callback, but we cannot await on it, right? That's the big problem here. Sorry, I had to sneeze. Ah. All right, anyways. So this is a callback. We need a way for us to wait until this is complete, and then we can return the user object. Okay. So we have to have figure out a way to wait. So what do you guys think? What's the answer here? The answer is a promise. So we're going to say const create create user, say command is equal to new promise. Okay. We have a resolve. We have a reject. Okay, and so inside of there, we're gonna stick this in here. Okay, so we have this resolve and reject. So how do we know if everything happened fine? Well, if there is an error, then we have to reject, and there's the error. Okay, and we have to say return. Okay, we want to make sure we escape, or else it can continue going down, so we don't want to do that. All right, so if there's an error, return reject error. Okay, cool. But, you know, if everything happened fine, then we resolve. But what do we resolve? We resolve what? We resolve the results. Okay, when you create a user, the results will actually be empty. There will be nothing in there because MySQL doesn't return anything. It's just empty. Okay, so that's all it is. It's just empty. Okay, so we have this promise now. So cool. So now the next thing is, okay, so now we need to await this create user command. Okay, the problem here is that what this create user is not async, so we have to make this async. Okay, we're gonna make it async, and then we're going to await. Okay, so we created this here, or actually, you know what we can do? Instead of doing that, because remember, we have to return a promise that resolves to a user. So what we should actually be doing is we should be returning a promise that will, oh, we can't do that like that. Okay. So we have another, but now we have this resolve reject. Ah, dang. Oof, 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 oof. How do I want to do this? Well, we're guaranteed that after we do, no, well, okay. Okay, I'll figure this out. Let's just make this asynchronous for now. So we'll tag that as async. Now we're going to await this. Now, if this thing crashes, so if something fails here, it means, obviously, something went wrong. There could be a number of reasons. One, the connection died. That's like the worst case. So your MySQL connection died. Number two, the information that you fed it was incorrect. For example, the username already exists. Or you didn't give it a username. The username was null. There's a bunch of different things that can happen. Okay? Because remember, we added some constraints. For example, username not null, not null, not null, not null. And this has to be unique. So there's some possible errors that can occur. Even if you gave it correct data, like, it wasn't null, but if the username already exists, that's an error. If the email already exists, that's an error because they have to be unique. Okay, so it can die. All right, so for now, I say we just leave it as this, and then let's just test it. Let's just try and test this. Let's just try and test this as it is right now. So I am going to, and then just say here console.log e. Let's just log the error here. So I'm just going to leave it like this, and then let's just try and test this. Let's just try and test it. So here, when we set up our app, I'm going to set up a app dot post. I'm going to create a route here called post / users. So on / users, I can actually create something. So remember, we have a request and we have a response. Okay, this is just for testing. I'm just going to do it really dirty in here. Okay. So the other thing I need to do is I need to have app.use express.json. Okay, so I needed to parse out the body as JSON. Okay. So for now, let's just do a response.end. We're going to kill it. And then we're going to do a console.log the request.body. At this point, the body should be a JSON object. We're going to ensure that that's the case by running this. Okay, and then we're going to use postman. And we're going to do a post on /users, and then we're going to feed it some JavaScript, a JSON object, and then let's just see what happens. Let's see if we're actually getting that information. And then we're going to send that information off to, okay, I'm not sure what happened there. So here's a post /users. Okay, go to body, switches to raw, to type JSON. Okay, and then I'm gonna send it nothing, just like that. Hit send. See what we get back. So nothing should happen here. Then when we go back, we're going to just log out what we got. So we got nothing. Cool. So if I were to do something like username is polymorphic. Okay. Then we have fname, Kevin, lname, Pacheco, email, mail@mail.com, and then password, pass123. Okay, so I'm going to send this, go back. Okay, cool. So we're getting the data as a JavaScript object, as a JSON object. Okay, beautiful. So this works. All right, now we got to feed this to our MySQL service to create the user. All right, so let's try it. Again, let's just try it. So I'm going to say const SQL, or I'm going to call this users service is equal to new MySQL user service. And when I did that, it automatically imported it here at the top. So that's cool. Now, what's the problem here? This MySQL service needs a connection. I need to feed it a connection. So now I got to create a connection. Okay, so I got to say, so again, this is quick and dirty. So require MySQL dot create connection, and there's an object in here. So the host, who's the host? Local host. If this was like how Jim was saying, if this was somewhere else, for example, we could do https rds.amazon.com / and then whatever you're in your MySQL ID, whatever the heck that is. You could connect, boom, like that. You could totally do that. You need to feed it the username, the password for authentication and shit. Yeah, so you do that. In our case, we just have localhost. What's the user? The user is root. Okay, now what's the database we're trying to connect to? It's bitter. All right, and that's it. Create connection, and that's it. And then we're going to have our little connection here. Now that we have our connection, we got to feed that into our MySQL service because our MySQL user service, because it's MySQL based, has a dependency on this connection. Again, this is a quick and dirty way of doing it. This is terrible. But again, this is just this test real quick. Okay. We'll go to, now we can say user service dot create user, and the DTO is technically this body. So I'm going to kill this now. I'm going to save it. I'm going to have two windows here. So here I'm going to log into my MySQL. I'm going to use bidder because I know it exists. Show tables. We have the users table, so I'm going to say select everything from users to show you there's nothing up my sleeve. It's empty. And let's just hope that this works. There's no error here. So everybody, cross your fingers. Send. Did it die? Ow! Something died. Must call super constructor and derived class before accessing. Oh, yes, I forgot about that. Okay. So under the MySQL, so let me kill this. Because this class is inheriting, before I can call this, I need to call super like that. That was it. Totally forgot about that. All right. So we have it here. Let's hit it again. Oh, okay. Oof. Okay, we have an error here. You have an error in your SQL syntax. Check the manual. I'm gonna go with it doesn't like the apostrophes there. Okay. That's what I'm gonna go with. I think that's the issue. I was wondering if that was going to be a problem, and I think it is. Okay, so I can just remove these real quick. It's because they have to be strings, and so I don't know how this is. God, okay. I usually don't do it that way. I usually have more dynamic, but let's see if that's gonna fix that. No, something's going on. At line 1. If name, email, password value. Oh, right. Okay. I think this is fine. I think these ones need it. Yes. Like I said, I don't do it this way because I hate dealing with this. You're supposed to, this actually is when I show you how you're supposed to do it on Friday, it's going to be a nice segue into some security problems. One of the security problems that we're facing right here is something called SQL injection, which is why I don't do it that way. That's why I don't really know how to do it properly, because I don't do it the bad way. I use something called, yeah, okay, this is really, okay. Yeah. Okay, that should have worked. Unless these ones are supposed to not have this. So this is why I don't like injecting stuff, because it scares me. Let me do it this way. Although I think this is not right. Let's try that again. Send. Okay. So I didn't like it here, and then I need it over there. Beautiful. Okay, now that that's happened, so you see that the error here is null. The results is an okay packet. It's just an object. And then the fields here is undefined because we haven't updated anything. Now you notice that before I said select everything from users. Now if I run that command again, you see this the first time it was empty. Now if we run it, we have a user in our field. There's our user ID at 1, username, polymorphic, fname, lname, email, password. So it's working, but we still have a long way to go, right? So one of the problems here is that we're opening ourselves up to something called SQL injection. I'm not gonna do it right now, but we do have a problem here because I am injecting it here, and so this is not a correct way of doing it. But we know that at least it's working. So it is working. We have from our Node.js, we're able to create users, right? So we can create another user. So let's just try it again. Let me try create a same user with the same all this information right here. So now we get an error here. Error, duplicate entry for polymorphic for key username. Boom. You cannot have two users with the same username. Okay, let me change this to polymorphic 1. Hit send. Duplicate entry for email. Duplicate entry, yeah, because emails have to be unique. Okay, so let me just change that. Mail1@mail.com. Okay, hit send. Everything went fine. Now if we run this again, now we have 2 users. Now you'll also notice that the incrementer, the 1 and the 4, it kept incrementing. This is a side effect of SQL, specifically MySQL, is if whenever you try to do something, even if it fails, the incrementer always moves up. It always moves up. I don't know if there's a way around that. I'm not even if you use something called transactions, it will still be the case. The reason why this happens is you put in you were put into a MySQL queue and you were assigned an ID already. The fact that you failed has nothing to do with MySQL. MySQL doesn't care. So the auto incrementer already incremented. There's no way of going back. Even if you use transactions, I think it still increments. That's why you see the 1 and then you see the 4, because I tried it 3 times and then it didn't work. So 1 plus 3 is 4. So now you get the ID of 4. Okay. So hey, so now we know it works. Sort of. It's working, but we still have a long way to go. Anyways, I just wanted to show you that it will work. And now that I show you that it works, hopefully you're a little bit more ecstatic about Friday. And yeah. So anyways, we'll finish these things up on Friday, and yeah, I'll see you guys all on Friday. Bye everyone.